Hey everyone, thank you so much for joining us this Sunday morning for Mind Detectives, How to Peep into the Human Brain or Mind. My name is Virat. I'm part of the Sugar Residence Achievers Program team. I'm being joined with my colleague Isha Saini and Professor Dipanjan Ray and Deeksha Rathore, who will be the panelists for this webinar. They're also the faculty and teaching fellow for one of our courses called Psychology Memory Labs. Uh, which is being offered as part of the edition 2 of our program. It's being scheduled for June 20th to July 12th. Uh, in this webinar, you guys will get to play as mind detectives, where you will examine fascinating experiments, surprising cognitive phenomena, and real fMRI findings to uncover how scientists actually study memory, perception, and decision making. I think that should be enough for the introduction. This is a very graphic webinar, and I will just hand it over to our panelist to go move forward with that. Over to you, Professor.
Hi, thank you. Am I audible? Can you hear me properly?
Yes.
Okay, so welcome everyone, and I'm also very much excited about this webinar because I usually teach university students, and this is the first time teaching schools children, and but today we are colleagues because we are all detectives today, and so. I don't know about you. I'm a fan of detective stories and novels, and uh, uh, who is your favorite detective? Like Hercule Poirot or Miss Marple or Sherlock Holmes, of course, and or maybe I don't know how many of us have read Feluda or Bomkesh Bokshi. So please feel free to share with us. So who is your favorite detective among all this? Or anyone else?
So could you repeat the question? Your voice just
So
for a second.
am I clearly like am I audible clearly?
Yeah. No, I was plugging in my earplug, so I just paused there for a
Yeah. So
second.
my question is, as the theme of today's webinar is detective, mind detectives, and we are
Mhm.
inspired by the great detectives like Sherlock Holmes and Miss Marple or Bomkes or
Yeah.
Feluda, or so who is or are your favorite detectives? What about you, Isha? Do you read detective stories or? Okay.
I really liked reading Sydney Sheldon's books as well
Oh,
because there's a lot of, you know, uh, things to be figured out in that. But I really like Sherlock because I watched all series of Sherlock that came out, Elementary as well, and also the one with Benedict Cumberbatch. So whodunits are kind of my favorite.
Does Agatha Christie count?
yeah, of course. Yeah.
Okay, then I would say her.
But who is the detective? Agatha Christie has many like detectives, like Miss Marple and Hercule Poirot and others. So who is your favorite detective?
If I had to
Not
go
that.
for just a favorite detective, then I would also say Sherlock.
Oh, okay, great. Uh, Okay, so I mean, like our work is a more like into movies rather than like people like us who are more into detective books, but they're referring to detective movies and series maybe. Okay, but of course, it started in a way from Sherlock Holmes, and who is our like vice chancellor of our university that we all study, and we'll follow some of. Can I? Uh, uh, so I cannot change slides, or I need your help to.
Yes, just let me know and I'll be able to move them. Yeah.
Yeah. So next slide, please. So
Yeah.
yeah. So this is some of the principles. No, not the previous slide, please. Yeah, so some of the principles that how Sherlock Holmes can guide even modern neuroscientists and psychologists. And so today's webinar is about some of the tools that we use to study our mind and brain, and we'll discuss about them shortly. But before that, why you are inspired by this theme of detective. So these are some of the principles that Sherlock Holmes like this from different cases. For example, the importance of observation, which is very important for a detective and for a cognitive scientist or a psychologist. You see, but you do not observe. The distinction is clear. Similarly, for the sign of four, when you have eliminated the impossible, whatever remains, however improbable, must be the truth. The principle of elimination. And this is also true for us. We'll see shortly that how we diagnose a neurological case or how we identify the function of a brain region by eliminating other possibilities. So this will be our guiding principles into this seminar. Similarly, the importance of data, that you might have interesting theories, but your theories must be guided by your data, by the observation, by the actual experiment. It is capital mistake to theorize before one has data. Insensibly, one begins to twist facts to suit theories instead of theories to suit facts. Again, from a scandal in Bohemia. So these are our guiding principles as like taught by the great cognitive scientist Sherlock Holmes. So with this, can I go to the next slide? Today's webinar, we are going to discuss some of the tools to peep into our mind and brain. Okay, and there are several such tools, and like these are only some of them. Okay, like for example, control laboratory experiment. Diksha will also, who is going to discuss more about this. But also, just like the detectives, they use very cheap tool, like just like their brain and intelligence, to very sophisticated tools like forensic, like experiments and so on. We cognitive scientists and psychologists and neuroscientists also use tool like, which are very cheap, like case studies or sometimes control laboratory experiments. You almost need no tools. You can just study your own mind and to identify certain laws governing your mind. On the other end, there are very sophisticated instruments like eye tracker, like electroencephalography or EEG, like virtual reality and uh, sorry and functional magnetic resonance imaging and so on. There are many other that, for example, magnetoencephalography and transcranial magnetic stimulation. But today we're just going to focus on two, three of those tools. So I'll discuss about case study, one of the most ancient tools to study our brain and mind, and fMRI, one of the most recent development. Okay. So, and then through puzzles, we'll study them through puzzles. So there'll be puzzles and cases to solve, and I'll ask each of you to solve the puzzle. Can you go to the next slide, please? Yeah, so we'll start with the case studies. But before that, a very brief like discussion about brain. So we all have brain, at least who are attending this webinar. I can guess there are other people out there who does not have brain, but at least we guess that we all have brains. And so these are our brain, and based on certain ridges and bumps and all this, so these are called sulci and gyri. So this my cursor is visible, or is it yeah, no, I think okay, so but you can see that those blue lines, these are like crevices. These are known as sulci, and those like bumps or outfoldings, they are known as gyri. And based on that, these are the anatomical landmarks in our brain. Our brain can be divided into a few parts, and they are called lobes, brain lobes. And so, for example, we have frontal lobes, which is, of course, here. And then we have parietal lobe, which is like here. We have occipital lobe at the back of our brain, and we have temporal lobe like here. So these are just, I mean, this is not that important to understand, but just get an idea about our brain. And in each brain lobes, there are several important areas that subserve different brain function. Okay, so now as detectives, we're going to identify and localize different brain function into different brain regions based on case studies. So what are case studies? Just like Sherlock Holmes and other detective cases, we also have cases. And case in Sherlock's case, it is just some anomalies, some abnormality, some death or murder. In our case, it is also murder kind of death of a particular brain region. So we have patients who have brain lesion because of maybe accident, because of brain stroke or something else, and and these lesions produce changes in our behavior, in our cognition, how we perceive our world, how we act on it, and so on. And from that, we try to identify the function of that particular region. So I'll present a few cases, and I'll ask you to diagnose. So there'll be a puzzle associated with each case. Okay, can I go to the next slide, please? So is it clear? Do you have a question? Please raise your hand and I'll stop and yeah. So okay, so this is a very interesting case in cognitive neuroscience. This is a patient, Moshe Louis Victor Lebogne, was admitted in a hospital near Paris, and after his death, Paul Broca, who's the scientist investigating the case, like this is the from the actual brain, which is still preserved after autopsy, and you can see here the frontal part of the brain, some region, there is a lesion which is very apparent. Anyone can identify the lesion, that a part is missing from his brain. Okay, so and this area was named Broca's area after the name of the scientist who was investigating the case. Now I'll present a conversation between Paul Broca and Monsieur Lebogne, was also known as Tan Tan by the hospital staff. Why, it will be clear very soon. And you have to tell me what is the function of that region. Is it clear?
We get
So
a show of hands in terms of a thumbs up or a yes in the chat box, because once you start hearing the clues, then we don't want to go over this. We want it to
and
be so that you're actually giving us the answers.
yeah, but if you have any confusion, please feel free to ask me, and we can again go back and ask. So this is a brain of Moshe Lebogne, and there's a lesion there in the frontal part of the brain. That is not that important. Now I'll present a conversation between Paul Broca, the scientist, and Moshe Lebogne, and you have to tell me from the deficit and from the symptoms, what is the function or what is the probable function of this particular brain region. Okay, can you go to the next slide, please?
Yes, Professor. I'm just resharing to make sure that the sound will be optimal as well. Yeah. Is this? Yeah.
Yeah, so this is the conversation with patient Tan. So the Paul Broca asks, "Good morning, Louis. Can you tell me your name?" And his response gestures warmly, smiles, Tan Tan. Broca, I see. And how long have you been in the hospital now? His answer, he pointed out the window, looked frustrated, and then Tan, Tan, Tan. Okay, Dr. Paul Broca, do you understand what I'm saying to you, Louis? If you understand, please touch your right ear, and the patient immediately touches his right ear, looking relieved that he's understood. Yes, Oishi. So let me present the question. Can I go to the next slide, please? The question is, the puzzle is this puzzle one. Based on this conversation, deduce the mystery like Sherlock Holmes. What exactly is the function of this damaged brain region, and what is it not? So can you go back to the previous slide? Uh, so please raise your hand and then maybe you'll ask. Okay, Oisi, please go ahead.
I think the Broca's area's function is mainly speech articulation as opposed to understanding, because that would be the Wernicke's area's function.
So you know about this. So I want a reply from someone who does not know about the function of the Broca's area. Anyone here who does not know about the Broca's area? This is the first time, and from uh,
Yes, Nishtha, go ahead.
yeah.
I think the function of that region is like speaking, or like, as someone already said, articulating speech. But it is because the person, like, which who we are referring to as Tantan, he can clearly understand what the doctor is trying to ask him, because he touched his ear when he was asked to, but he could not reply to him when he asked his name or the time maybe.
Hmm. Great. So there's no problem in understanding speech. The problem is in production or articulation of speech, and the intelligence is also fine. We can see the ability to move and the motor action is also fine. So the is a very local, like the localized function that is affected, which is the production of speech. Can you do the next? So anyone has any confusion, please raise your hand. It's completely fine. Even if your answer is wrong, it is completely welcome. You can say silly things here, because by only say silly things, you can actually learn. So that's the main purpose. Okay, so can you go to the next slide, please?
I
Uh,
think Shania has raised her hand as well.
oh,
So,
please go ahead. Yeah,
yes.
I cannot see all of them, so please
Thank
Yeah.
you.
switch off mute. Yeah.
If so, you said that because of the part of the brain that's damaged or not there, his understanding is okay and it hasn't been hampered, but the verbal communication is what's been affected. But if he's able to say like the word tan, right? So why is it that he can articulate only the word tan and nothing else?
That's a very interesting question. Yes. So we can see that. Uh, I mean, it's very. We can rather see that. Let's say that that is a very, like, the ability to produce speech is
Mm-hmm.
very limited. Okay,
Mm-hmm.
and it's also interesting that many. So these are the patients of what we call non-fluent aphasia. Aphasia is a kind of
Mm-hmm.
inability to produce speech, and in many other patients of Broca's aphasia, we know that when the assault, like the neurological assault occurred at that particular time, for
Mm-hmm.
example, when the stroke occurred, the words that they were producing, usually the
Mm-hmm.
vocabulary is limited to that particular word. We don't know
Oh,
because there is no history, but probably he was speaking something like tangent or something like that in
yeah.
French.
Mm-hmm.
And we don't have any like
Oh.
documentation for
Mm-hmm.
tan or Le Bogne, but we know for other patients, contemporary patient of Broca's aphasia, usually the words that were being spoken at that time is
Mm-hmm.
the word that they usually use, can
Okay.
only use. It is restricted to that. But it's a very interesting question. We don't know the
Thank you
answer to
so
all these
much.
questions. Yeah. Can I go to the next slide, please?
Professor, I also have a question as a
Sure, sure.
student here. An interesting bit I noticed is that it's only his verbal communication that's affected. It's not the non-verbal communication, because he's gesturing and he's all able to, he'll have a warm response, or he'll get frustrated and he'll be able to showcase those emotions as well. So it actually kind of points towards how verbal communication is not the only way we express our emotions too. And that seems to be a
Absolutely,
complete.
absolutely. But also it depends on the extent of lesion, because for case studies you never get a very like localized like lesion. So in some patient of Broca's aphasia, even the written communication is affected. So yeah, I did, but you rightly pointed out that at the same time, how like the so-called segregation of function in our brain, how we have in our brain a region that are specifically important for verbal communication, but not important for other communication, which is also important for memory. That during the course we'll discuss that how a specific part of memory can be affected. For example, our memory to recall a particular event, but not other type of memory, like swimming or cycling, depending on which part of the brain is affected. So this is very interesting. I mean, there are many aspects of brain that is really interesting. Can I go to the next slide, please? So this is another patient. So after Paul Broca, Carl Wernicke, he identified a group of patients where a different part of brain was affected. You can see this one of Wernicke's patient. So can anyone tell me which part of brain is affected from the, just we discussed a few like maybe minutes before, the different parts of the brain. For example, Broca's areas mainly affects frontal part of the brain, which is called frontal lobe. Now we have parietal lobe, temporal lobe, and occipital lobe. So can you tell me this Wernicke's area, which part of the brain is it? Uh,
Yes, Riya,
some
go ahead.
Temporal.
Temporal, absolutely correct. So this is the temporal lobe, and where the Wernicke's area, and these scientists are very modest. You know, like after identifying area, they usually name it after their name. So, like for example, Paul Broca named the area as Broca's area, Wernicke's area named it Wernicke's area. Anyhow, so can you go to the next slide? And this is a conversation from Wernicke's one of the Wernicke's patient. So, yeah, can anyone please read this, any student, and tell me what is the function of Wernicke's areas from this conversation?
Would anyone like to volunteer to unmute and read it out loud for the entire class?
Sure. Can I?
Yeah, go
Sure,
ahead.
sure.
Yeah. Dr. Carl Wernicke, good morning. Can you tell me what brought you to the clinic today? Patient. Yes. Thank you. The telephone is barking on the blue glass. You see, and when the window speaks, the calendar spins around the corner very loudly. Dr. Karl Wernicke nods gently. I understand. Now please look at this cup on my desk. Can you pick it up for me? Patient smiles warmly, looks right at the cup, but does not move towards it. The master of the ship is pouring juice into the shoes, completely blue. Would not you say so? Wernicke, please just point to the window. Patient happily waves his arms around, entirely missing the window. The electricity is dancing on the ceiling. Yes, exactly.
Great. Can I go to the next slide, please? So the same puzzle, but this is puzzle two. Based on this conversation, deduce the mystery. What exactly is the function of this damaged brain region and what it's not? Please raise your hand.
Yes, Tanushree, go ahead.
Um, am I audible?
Yeah, yes, you are.
So I feel the function of this part, what is not, is that he can produce speech, but it's not really um understandable. It's not his string of thought doesn't make any sense. It's just random words and babbles.
So first of all, the production of speech is fine. He or she can produce speech, articulate speech, which is fine. Then what is the problem? What do you think?
The problem I feel is that it does not make any sense, and also it has no correlation to the question that's being asked.
So there is problem with understanding or comprehending
Understanding, yes.
the speech of Wernicke, or even himself or herself.
So
So
I
there's a
think the patient is
yeah.
understanding, but they just don't know how to respond to it, or they can like hear what he's saying, the doctor's saying, but cannot produce like an appropriate action or like a reaction to it.
But what? So why do you think that she or he can understand or comprehend the speech?
So every time the doctor asks something or says something, there is some response to it. It's not like there's silence. The patient does respond to that, but it has no relation to the question.
Okay. Any other answer? Anyone else? Any other detective?
Hello?
Shania, go ahead.
Yeah, thank you. I feel like he is understanding that he is being asked something or he needs to respond to the doctor. However, I don't think he is able to form, and his physical speech has not been affected. He's like in the previous case, we saw that the patient was able to understand and comprehend, but he was not able to speak of anything other than the word tan. But here, he is able to form words and string them together. However, even though he comprehends that he is being asked something and needs to respond, there is no link between the words he's actually speaking and what he has comprehended. Like, he knows that I need to answer, and he does try to physically, he is speaking, but there is no link. So I don't think he's able to chain thoughts together. I think the understanding has been hampered.
Hmm. Yeah, so I mean, of course, only from this conversation it is very difficult to like conclusively
Mhm.
reach to a conclusion. But
Mhm.
based on these and many other observation, including neuroimaging and others, now we know that Wernicke's areas is important for understanding speech and comprehending speech. And so this is not the area related to like it is not a primary auditory area which processes speech and processes the like the auditory information, but rather to understand speech, both spoken by others and himself or herself. So here you can see that, as you like all of you like mentioned, that there is no problem in producing speech, but the problem is understanding own speech and the spoken language produced by others, like here the Paul Broca. So this is the, so can you go to the next slide, please? So this is some of the so these are some of the like the language areas in brain. So Broca's area is primarily involved in production of speech, whereas Wernicke's area is primarily involved in comprehending or understanding speech. And there are many other areas, of course, like angular gyrus and so on. And there is a nerve bundle connecting Wernicke's area to Broca's area, which is known as arcuate fasciculus. Okay, so with this understanding, can you now go to the next slide? Here, I'm not going to present any, so I'm just going to present a conversation. And now as you know about Broca's areas, Wernicke's areas, arcuate fasciculus, and all this, can you tell me which area of brain or which is affected here? So who's going to read it? I just randomly ask someone, like maybe Arshia.
Yes, sure.
Yeah.
Conversation with a patient 2026. Doctor, good morning. I'd like to test your speech today. Can you tell me what you had for breakfast? Patient, oh, I had an wonderful breakfast. I had eggs, toast, and a nice hot cup of coffee. Doctor, excellent. Now, I want you to simply repeat exactly what I say. Repeat the word president. Patient frowns, concentrates hard. Oh, the man in the White House? The leader? No, that's not it. I know it, but I can't say it. Doctor, let's try a simpler one. Repeat after me. No ifs, ands, or buts. Patient, frustrated. I know exactly what you just said, but the words won't go from my ears to my mouth. I just can't repeat them.
Thank you very much, Arshia. Thank you very much. So can you go to the next slide, please? So the question is, the puzzle is based on this conversation, which specific brain area or pathway is affected here? So someone mentioned that the understanding has been affected. Sania, did you mention that?
No, that was for the previous case.
Okay. So no, not Sania, but anyone, someone else. Can I get anyone?
Prerna has
Prerna,
raised her hand. So, Prerna?
Prerna? Yeah.
I think there's a problem in the mirroring of any words. So
Okay.
if patients are able to understand and they can also make connections because when asked to repeat the word president, they were able to understand that they're in the White House and it's a man in power, but
Mm-hmm.
they're not able to mirror that word, and I don't think they're able to make that connection.
Yeah. So there is some disconnect between the comprehension and production. They can fully comprehend. They can also produce speech. There is no problem in that. But when you have to connect what you process and comprehend, the spoken words by others, and repeat it by using Broca's area, there's a problem. And if you go back to Isha, can you go back to the previous slide, the brain image? The brain image, the previous one. So here you can see this arcuate fasciculus. It connects the Wernicke's area to Broca's area. And this is a typical example of conduction aphasia. There is no problem in spontaneous speech. There is no problem in comprehending speech. But we usually diagnose them by asking them to repeat after me, after the clinician, that can you say refrigerator? Can you say president? Can you say some complex word? Then they completely understand that the word, and but they have difficulty repeating the words. So that's why the brain is so fascinating. Okay, so I think we're running a bit late, so I'll just maybe. So if you have any question here, please raise your hand. Maybe you can make it more interactive. Okay, great. So let's go to the next section, which is about eye tracker. And eye tracker is one of the like recent developments, in the tools that we use. And in our lab, we have some of these instruments. We have EEG, we have eye tracker, we have um, virtual reality. We have set up a virtual reality lab here where Diksha and some other lab members are working. So about eye tracker, how many of you know about eye tracker? Can you raise your hand? Okay, so great. So let me very briefly tell you about what eye tracker does. So eye tracker is a like instrument where they emits infrared light that we cannot perceive like the humans, but is reflected from our eye, and it produces a corneal. In our cornea is the central transparent part of our eye, and here there is an image is reflection is produced, and that is captured by a camera which is usually integrated, infrared camera integrated in the eye tracker. Okay, and by this we can measure the point of gaze where we are looking at when I'm say reading something or looking at an image or photograph or a video or something like that. Okay, so can you go to the next slide, please? And so this is the how like this is I'm not going to the details of the complexity of the thing. So this is the you can see there's a corneal reflection, and by the relative position of the center of our eye, which is the pupil, which is the central very black circle, and the corneal image, we can by statistical method we can detect where the person is looking at. Okay, can we go to the next slide? So when you're looking up, when you're looking down, the relative position changes, and accordingly we can detect. So now I'm just going to present two result from, and we can create heat maps. Like we present stimuli and we recruit participants, and we can produce heat map where most of the participants are looking at. Okay, so I'm just going to present two results, two heat maps from eye tracker studies, and you have to tell me what is the implication for our mind and brain. Okay, now the next slide. The first question: what is this painting called, and who painted it? It's a very famous painting. Uh, it's in Milan. Yeah. Yes, please go ahead.
I
Abhishek.
think this is the Last Supper by Leonardo da Vinci.
Absolutely correct. So this is the Last Supper by Leonardo da Vinci, and the researchers they recruited many participants. They asked them to look at this painting, and they produced the heat map. So can you go to the next slide, please? And the heat map is about where the different like all the participants are looking at. Okay, so from this, go to the next slide, which is our puzzle number I think 4, that look at where all the eyes gather. What insight do you get about our mind from it? Where do we usually look when we see people? So can I go back to the previous slide again? Yeah, who is going to tell me? What is interesting about this result?
Go
Can I?
ahead, Nishtha.
Oh,
So from the heat map, I can tell that people like usually notice everyone's faces when they look at them first, because all of the like the
Yeah, so
red markings
red
on
means more like attention. Yellow means less attention here. So you're absolutely correct that when you look at images, say at people, see people, we primarily focus on their faces. It might have some evolutionary benefit because we want to understand the intention, the emotion, and like what they're going to do and all this thing. So this is what we can infer from this relatively simple tool of eye tracking. Uh, okay, so can you go to the next slide, please? Next slide. This is another study by a neuromarketing company. So there's a huge application of eye tracker in neuromarketing. So this is a Sunsilk ad, Sunsilk shampoo ad. So this is the first advertisement for print media that they created, and they recruited participants. And this is the like the first one is the eye tracker, like the heat map, and then they change the advertisement format based on the eye tracker study, and this is the second version of that. So can you tell me the puzzle number 5 is why they changed the based on the heat maps, why did the advertiser change the ad after looking at the eye tracker study? Yeah. Prerna, please go ahead. Prerna and Ria. Yeah.
Yes, so I think when the woman is looking towards the product, it makes it seem more desirable in the sense that obviously when you're looking at an ad and the woman is looking at something else, you'll want to, there'll be curiosity towards what the woman is looking at. And I think that makes the ad more marketable.
Okay, it's not only about desirability, there's something else more objective here. It is related to desirability, maybe, but there's something else here. Like something was missing in the first ad that like was intended for. And what was that? And what modification they made and how it changed? Adrija?
Yes, am I audible?
Yes, you are, Adrija.
I'm thinking that maybe in the first part, the product was not visible because everyone is looking at the woman's face. And in the second
Absolutely.
part, when the woman is looking at the product is more visible.
Yeah, so in the
Just a
first
moment.
advertisement, the model was looking at the viewer and no one is looking at the name of the product even, which was intended for. In the second version, as you mentioned, Adrija, they changed the eye gaze of the model. Now she's looking at the name of the product, and we follow the eye gaze. And because we want to interpret the intention that is somehow hardwired in us, and now we can see the name of the product, most of the participants are looking at it. So this is an application of like a practical application of eye tracker in neuromarketing. Okay, thank you, Adrija, for your answer.
Well,
Okay, can you go to the next slide then? Okay, so now the last section that I'm going to present is one of the most sophisticated the tools that we have to investigate our mind and particularly brain. Okay, it's called functional magnetic resonance imaging. We call it fMRI. And can you go to the next slide, please? So we use the same MRI machine. Okay, I think most of you know about the MRI machine and you know the MRI scan when you but those MRI scans are structural scans, okay, in hospitals, like when we suspect the doctors or neurologists suspect a tumor or stroke or something, we order MRI scan. But the same MRI scanner can be used to reconstruct the functional magnetic resonance imaging, where I don't know any of you have seen these kind of images in scientific papers where like we can identify some certain brain areas lightened up. It's not actually lightened up. It's like just representing the brain areas active in a particular function. Okay, now to the next slide, please. So this is the different types of imaging that we can create using MRI scanner. The first one is the structural MRI, which is the most common one, where we can, like, this is about the structure of the brain. Okay, so like the different brain areas, where there's a tumor, where there's a stroke, where there's some other changes in the brain and so on. The second one, I'm just not going to that. The third one is the fMRI, which is functional MRI that you're going to discuss now, where you can identify for a certain task, like when you are reading, or like processing color, or like listening to music, and when you are emotional, when you are like recalling something, which part of brain is active. Okay, so this is the function of functional magnetic resonance imaging, fMRI. Can you go to the next slide? I'm going to discuss about the basic principle of fMRI in a very simple language. Then I'll present like the fMRI data, and you have to tell me what is the function of that particular region of the brain. So this is the in very simple language, the basic principle of fMRI. So it's like kind of indirect inference. The idea is that when a part of the brain is active, so then it needs more oxygen, and oxygen is carried by blood in hemoglobin. So more blood flows to that area, particular area. This is known as neurovascular coupling, but it's not important to remember. So more blood to that area, and particularly more oxygenated hemoglobin to that area. Now, oxygenated hemoglobin has different magnetic property compared to deoxygenated hemoglobin. In other words, the blood that contains oxygen has different magnetic property compared to blood that does not contain oxygen. And this change in magnetic property can be captured by MRI. And so and this is called bold signal, this change in magnetization. And this bold signal is called blood oxygen level dependent signal, is a proxy measure of activity in that particular brain region. Okay. Uh, so if you have any confusion, please raise your hand. I'll repeat it. Please feel free to tell me that I didn't understand anything that just you mentioned. You just mentioned. So I'll just
Yeah,
repeat
sir,
it.
actually, could you repeat just this part, the functional
Yeah, so
MRI?
the main idea is to identify which part of the brain is active in a particular task, during a particular
Mhm.
task. So how do this? By Bose signal. So
Hmm.
Bose signal, it represents change in the magnetic property of a particular brain region. And why there's a change in the magnetic property in region which is active? Because when a part of the brain is active, there is more blood flow to that area, carrying oxygenated hemoglobin. Now, oxygenated hemoglobin compared to deoxygenated hemoglobin has shows different magnetic property, and that is captured by fMRI. Okay, and by and then we indirectly infer that part of the brain must be active because it is showing heightened bold response. It will be very difficult to like explain it in like that can be a full semester course
No,
on
I
this, but
understood.
yeah, but I mean, so if I go to the next slide, I think it's a little bit more
Okay,
clear.
okay. Yeah.
So, so what I do, no, I think you can skip this one, then go to the next slide. So this is the MRI scan that you have is a three-dimensional, like, and now we take voxels. So what are voxels? So you know about pixels? Each of you know about pixels? Like these are the squares. So when you see in the mobile or television, like there are small squares that each images consist of.
Yes.
So those are pixels. These are two-dimensional. Now in MRI data, is three-dimensional. These are three-dimensional pixel or voxel. Now we take one voxel from the brain, and then we present two conditions, condition A and condition B. Here you can see condition red and condition blue in this particular image. And this is the bold signal during when the condition. So for example, condition one could be the a baseline condition like a simple square, and condition B can be the image of faces. Okay, now if we here we can see, so can we tell that in condition blue here the bold response is much higher compared to condition red, or the vice versa? So this is the time series from one particular voxel, that is the blue voxel in this image, and we present different two conditions, condition 1, condition 2, condition 1, condition 2, like one after another. Each condition may be presented for 2 seconds. Okay. Now this is the bold response, how it is changing when the condition 1 corresponding bold signal, when the blue condition is presented and red condition is presented. Now, can you tell from this time series, of course, actually we have to implement statistical test and all this, but just looking at this figure, can you comment that in blue condition, the bold signal overall on average is higher than condition red? Anyone? Or if you have any confusion, please ask me that any clarification you need. So what we, yeah, so this is the line that we drawn here is the bold signals, how it is changing over time. And the condition A, condition red and condition blue are two conditions that are presented each for say few seconds. And this is the corresponding change in the bold response. Now just looking at the graph, can you tell me in that particular voxel, the bold signal on average is much higher in blue condition compared to red condition or not? Whatever you think, you just tell me. There's no like, I mean, it's completely fine if your answer is wrong.
Yes, very.
Yes, Ria.
Actually, I not agree with this
Okay.
because the whenever it goes up, it
I cannot. I cannot hear you, Ria. I cannot hear you.
I, are you able to hear me?
Yes, yes. Now I can hear you. Yeah.
Yes, I'm saying that whenever the line goes up or down at the
Hmm.
highest maximum or minima, it appears red, but in between them, the blue line appears.
Yeah. So you think that it's very difficult to comment whether it is higher in blue condition compared to red condition, right?
Yes.
Yeah, so that's why actually the data, what I actually why I presented this data to so that you can understand that the actual data is very noisy, and to interpret it, you have to implement some statistical test, t-test or something like that. But if you ask me, I think that overall, though the data is very noisy, if you just check, so this is the corresponding like bold signal. The corresponding bold signal is higher in blue condition compared to red condition. Okay, so but of course, I agree with you that it's very difficult to conclude from this data because data is ephemeral data is very noisy. Okay, but you get the idea that how we interpret it. Okay, so now let me present with three examples, and I think we're running out of time. Maybe this is the last examples. So three examples of and puzzle. Okay, so this is our puzzle number 6, and I'll ask you. So here you are going to present the bold signal, the ephemerized signal from a particular voxel in the brain, and we'll also present two conditions that are presented to the participants whose brain was recorded in fMRI. And you have to tell me what is the function of that particular voxel based on this result. Okay, can you please play? So the bottom row, you can see the stimuli presented, and you can see the bold response. Can you again, please play again? So two images are presented one after another, and these are the, can you please pause here, Isha? Yeah. So you can see, and this is the from this particular voxel in red on the top row, and these are the fMRI signal from that particular voxel. And these are, so the idea in fMRI is that you present two contrasting images or stimuli that should be same as far as possible, except only one variable that will change, and that is the variable that you are testing, the function. Okay. So from this clue, can you tell me what is the functional speciality of this voxel based on the fMRI signal? Nistha?
Um, is it something about identifying or recognizing color?
Absolutely, absolutely. So you can see the both the images that are presented, they are identical except color. Okay, their shape, size, and everything is same, contrast, but except one is colorful, another is black and white, and the bold signal is much higher when the colored images were presented compared to where the black and white images were presented. So from that, we can conclude that this particular brain region from where the bold signal was recorded is involved in color processing, isn't it? What do you think? Yeah. So okay, great. So who is going to solve the next puzzle?
Should we move on to the next slide, Professor?
Yeah, please, please. Yeah. Yeah. So this is the visual stimulus which is presented to the participants and is the corresponding bold signal. Yeah. So you can just play the whole one. Can you please again play it? Yeah. Yes. Who is going to? Uh, uh,
Adrija raised her hand first, so I think she gets the first chance.
okay, Adrija, what do you think?
In
What is,
this image, I think that it is something secretion of hormones or emotions, like something,
no, so
probably.
let me clarify first. So this is just a visual image shown to the participant, and sometimes it is there are just white dots in black background. Sometimes they are static. Sometimes they are moving, and this is the corresponding bold signal.
Probably it is something hormone secretion and emotions, I think.
No, there is nothing here. It's emotion. I mean, I don't know whether you can read emotion from that, but no. So, Nishtha, I'll come back to you, Adrija, later.
Oh,
What do you think? Yeah, Nishtha?
so I thought you were telling me that you will come back to me later.
No, 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 no. Yeah, yeah. Please go
Okay,
ahead.
so I think it's something about identifying movement.
Absolutely. So, whenever the point's moving, there's increased bold signal, isn't it, Adrija? So, can you play it again? Whenever there is a movement in points, there is increase in the fMRI signal. And whenever they are static, it drops down. So from that, we may infer that probably that particular voxel is involved in movement processing. Okay. So there are actually two, go to the next slide, please. There are actually the different brain regions in the visual brain. One is ventral stream and dorsal stream. So the first voxel is from the ventral stream, which is involved in processing what information to identify the object, like the color, texture, shape. And the second voxel is from the dorsal stream, part of the brain in the near the parietal region, which processes where related information like the location, movement, velocity, and so on. Anyhow, the last slide, which is the next slide, which is also my last slide, It is the puzzle number 8. And again, you have to tell me what is the function of that particular voxel from which the fMRI signal was collected. Not Nishtha or Adrija. I'll take answer from someone else. Gunisha, and who else?
I don't know. Is it sound?
Yeah, so it's processing of sound. So it's actually primary auditory cortex. So you're absolutely correct as a detective. So next slide, please. Case is like all the cases we have solved together. I don't know whether we have time for Diksha. I think Isha can guide us whether we have like we have to end, but because
I think we can try to fit in something very quickly. Oh, no. I realize that there are tasks that are planned. I'm just going to stop sharing my screen for a moment and we can try to see if we can fit in these tasks, or otherwise, we'll try to schedule something else to do as a follow up. Diksha, would you like to conduct either one of the tasks instead of both of them?
Yeah, I can conduct one task.
And would all of the attendees like to participate, or would you like to wrap up? It's entirely in your hands because this is an interactive session. We'll leave it up to you. I'm more than happy to extend, but I know that some of you may have other plans as well. And I will till then ask for Diksha's input
Yeah.
in terms of whether should we start with task 1 or task 2.
Task 1 would be fine.
Okay, perfect.
Yeah, I'm completely fine. Like, so because I mean you cannot limit like learning like that. You cannot
Yeah.
like constrain the time to learn. So I'm completely fine. So yeah, please go ahead, Diksha.
I'll share my
Thank you so
screen.
much, Professor. I'll just share the screen, Diksha, and over to.
Isha, can I share the screen, please? Because I'll have to.
Yeah. Go ahead. I think you should have the option to let me know if you're facing any challenges.
Yeah, I hope you can share my screen, see my screen.
Yes, I can see your screen, Diksha.
Okay. Okay. Hi everyone. This is so good to see you all, and I hope you've all been doing fine. Um, I'll just take 5 minutes of your time and we'll just go through one task. And do not worry about this complicated screen. So far, we've been looking upon how to detect the brain function through what is something that is visible from the outside, right? Like case studies, functional MRI, or virtual reality, where does your eye look? So all of these are ways of coming to the theme back again of detecting the brain function, detecting what is inside, how you process information. So one of the things that you also saw was controlled laboratory experiments, and this is one task that comes under that head. So do not worry about this complicated screen. I'll just run this experiment, and then I'll let you know how to go further. Just a sec, it takes a little bit of time. Okay, so do we have any student volunteer for this? All you have to do is simply in this game, you will see two butterflies. When you see a purple butterfly, you ask me to respond to the left butterfly. And when you see a yellow butterfly, you ask me to respond to the right butterfly. Okay, so it doesn't matter where the butterflies are located. The colors indicate which side to select.
Someone who has not responded yet, like maybe Maida or
Yeah.
uh, Sasha.
So this will give you a flavor of how participants perform psychological experiments in real time. Anyone?
Please volunteer before we start picking you out by name.
So all you have to do is just ask me to press left or right. Left or right is all that you have to respond to. Just left or right, okay?
So if it is purple, you have to say left,
Yes,
and if it
like
is
that.
okay,
If it is purple, you have to ask me to press left. If it is
it is
yellow, you have to ask me to select left.
right. Okay. So yellow, we have to yellow right, purple left.
Yes.
Okay. So who is our volunteer?
Who's our volunteer for this experiment? It's a chance for you to be able to do a psychology experiment live. So we have Ria. Is there anyone else who would like to do it? I'm just trying to give more chances to people who've not had the chance to respond. Otherwise, it's going to be fastest finger first, and Ria gets to do it.
Or Arna is here.
Arna, would you like to do it? I think
Okay.
Professor will go ahead with Ria because I'm not
Okay.
getting a
Sure.
response. Yeah.
Sure.
All right, Ria. Can we just do a really quick test with your mic so that we can hear you? Because it's going to be entirely based on your response. Whatever you tell Diksha is what she'll do.
Yeah, sure.
And
Hi,
can you say
Ria.
left and
Am
right so that she can hear you and see if that's working?
I okay? Left
Huh?
Yeah.
and right.
Yes, perfect, perfect. I can hear you, Ria. I hope you're doing well. Let's start with the experiment. All you have to do is just tell me left or right.
Right, left, right, left,
Mhm,
right,
mhm.
left, left, right, left, right, left, right,
Mhm.
left, right, left, right, 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 left, left.
Perfect. Thank you so much, Ria, for participating. Okay, let's get to the slide and see what this experiment implies. Okay, so usually you have proper specific numbers which I can point to you that, okay, Ria, you took this much amount of time in responding to the left butterflies or the right butterflies or the purple or the yellows. And how it would come out usually is that it would take longer for you to respond when, say, the left butterfly is on, when, say, the yellow butterfly is on the right, but to your screen it would be right, but it's actually appearing on the left. Okay, so this contrasting information, and you take a little more. Okay, what rule was I asked to respond to? That okay, the yellow butterfly has to be responded on to the left and not to the right. So this is one such task that gives you an idea that participants respond to the location of the colored butterfly in this case more automatically than performing the goal-oriented task. So it's nothing to do with your behavior per se, but it's a general cognitive phenomenon, as in how your mind performs tasks and actions that you're more likely to perform automatically when it comes to location of the butterfly, as in, okay, it's the purple butterfly, and wherever it appears, I'm more likely to say it's that. So that gives you an idea, and coming back to our theme, that it gives you an idea about the fact that you can conduct these simple psychological experiments and gain a sneak peek into how your brain functions. You can get an idea of how much reaction time it is for automatic processing, which is one such thing in brain function. That automatic processing, let's say for instance, you have you're a pilot and there's a cockpit in front of you, and the lift engine is it's faulty, and you have to respond immediately to that. You can't take time as a pilot. But if, let's say, for the button for the left engine is on the right side, so it's conflicting information and it'll be taking more time for you to press that button. So that's how these experiments give you an idea that, okay, design the cockpit in such a way that the left button is to the left side of the is to the side where the engine is located. So simple experiments, but give you detailed, insights about how the brain functions. And this gives us, this adds to the idea of how we can use case studies, lab experiments, virtual reality, and all of these fascinating methods, some which may be looking complex to you. And of course, our job as tutors is to go over in depth over the course. And um, this is one such way to have an experiment and get a sneak peek into psychology, cognitive psychology specifically. So that is it from my end. Thank you so much.
Thank you so much, Professor Dipanjan and Diksha, for actually walking us through so many case studies and letting us play the role of detectives for a while. I have to admit, I have had so much fun in the last 1 hour learning so much more. And, to be able to see that all of these complex concepts can be broken down into easy things that where anyone can actually play the role of a neuroscientist and give some conclusions in terms of whether participants are responding to sound or whether they're responding to location or color. So I think that has been really, really fun. With this, I'm just going to start sharing my screen again and start wrapping up the webinar. Thank you all to all the participants who stayed with us for this extra hour as well. One thing that I can promise you is that once you do join the course, you would have 2 hours. So usually you will never end up having this issue of that, oh, we're going over time. Usually we stick to time when it comes to the classes. And another good news is that this course is being offered in addition to, so we are still accepting enrollments. So please feel free to enroll for the classroom if you actually want to step into the role of neuroscientists and cognitive neuroscientists who are actually designing experiments of their own. There's a lot of fun stuff planned for the students in the course itself. This has just been a small glimpse into the things that you'd be doing in the classroom and how you'd be learning. And I hope that has been very insightful for all of you. I know that one of the conversations we had in the beginning of this webinar was that I haven't been able to study psychology in school and I want to learn more. So I hope you're walking away with the learnings that we've had this in this 1 hour. We are accepting applications till June 7th. So please fill out your applications early. You'll also be receiving extended opportunities post the course. So that's very exciting. Professor Dipanjan's lab, the one that he'd mentioned, the MBBS lab where Diksha is also working, you may have the chance to visit that, and also the virtual reality lab at Ashoka. So instead of just looking at the findings, you'd actually be able to tinker with the materials yourself or see the PhD students tinker with them in front of you. So I think that's really, really exciting. And I've almost always had so much fun whenever HAP students have come on campus. So that's something to look forward to. These are the ratings and the experience that they've had. But at this point, you've kind of gotten a taste of the learning yourself in this webinar. So I'm just going to skip past this. You can use this QR code to enroll into the classes. And if you have any questions, please feel free to write to us at horizons@ashoka.edu.in. We'd be happy to take those questions. And There is scholarship application. There's a question about those. We did have those open, but I'm so sorry we closed those early on in March. So that's why please keep an eye out on our social media channels and also the emails that we send out so that you can enroll early with the scholarship initiatives that we do offer. But right now, the scholarship applications are completely closed. I'm so sorry. Do we have any more questions that are coming in? Please feel free to ask us. And if you have any questions about the activities that were done today as well, you can ask Professor Dipanjan and Diksha as well.
Shania has her hand raised.
Hello?
Yes,
Hi,
Shania.
Yeah, please go
Yeah,
ahead.
first of all, I would like to say that I really did learn a lot from the seminar because, as I said, I wasn't able to learn from school much, and I really did enjoy. Thank you so much for that. And also, this addition to that you've displayed on the screen, is this the same one as the like the internship program, where we like physically come to Ashoka with the different programs, or is this like a different like a related one to the seminar?
So, I'd like to take one moment to introduce Ashoka Horizons Achievers Program, and I'll stop sharing my screen. This is an online program, so you can actually join in from Bangalore. You don't have to come to campus. This will start on, can you help me in remembering the date? Yes, June 20th and till July 12th. You have weekend only classes, and you can also have office hours over the week with your teaching fellow. That's going to be Diksha if you enroll for this course. So, this is not YSP. This is going to be Horizons, where it's
Okay.
actually online and you can join in from anywhere. We also have students who are joining in from outside of India, so that ends up being quite interactive in terms of the cohort bringing in their own different learnings as well.
And the YSP program, that's closed, right?
Yeah, that's closed.
Right,
That
like so.
closes in the beginning of May.
Yeah, I was supposed to be joining YSP last year, but unfortunately the shifting happened, so I couldn't. So just to be clear, the YSP program, I think you start taking students in from March, right?
No, we start taking students in from December itself from this
Okay,
year.
okay.
So if you want to apply for next year, you'll have your applications open in from 1st of December, and we accept students till April, I think. Yeah, we usually have a final deadlines in April.
Okay, thank you so much. That's all.
Don't worry. Yes, Nishtha.
I think in the last YSP webinar, you were saying something about the other edition of Horizons Achievers program that will be there in winters. Like, any updates on that?
I'm very confused because I wouldn't have been there for a YSB webinar. I would have been there for Horizons. But we had a winter edition course happen last year that was on writing your college essay. But right now, we do only have the summer catalog on display. We're not too sure if we're doing a winter edition just as yet. But if you're interested in a particular course and want it in winter, please do write to us. It helps us in designing the catalog.
All right, thank you.
No
And I would
worries.
like to say that today's session was really good, and I got to learn so much, and it was so fun. It was really good.
Thank you so much, Professor Dipanjan, for making learning so fun. Especially when things, I think, about everything that I've noticed in a psychology classroom, even at a collegiate level, is that people get really, really worried when anything related to biology or mathematics comes in for psychology. But I think this made it so much more accessible, and I think that's why we were able to have so much fun while learning about different parts of the brain as well.
Personally, I cannot learn if it is not fun. So that's why I always try to create things that are also fun. But also, thank you for that.
Yes, Shania, is this from earlier or do you have
No,
another
no, I'm so
question?
sorry. I forgot to lower my hand.
No worries at all. All right. Thank you so much, Professor and Diksha. I hope you have an amazing weekend. And we're looking forward to the classes that happen from June 20th onwards. Thank you to all the attendees for being so patient and staying with us as well. And I share the same opinion as all of you. This was really, really fun. Thank you all.
Thank you all. Thank you all. Thank you very much.